What's up, everybody? In this video we are going to cover dot product of vectors. And yes, I said dot product, which means there's going to be more than one video about products. But this one's going to cover the dot product, and it's pretty easy to do. If you take two vectors and you multiply them, really you're just multiplying the component of your i's and adding them to the multiplication of the component of your j's. And one of the things it does, it tells us if our vectors are orthogonal. Now again, with vectors, a lot of things just have their own fancy vocabulary, but orthogonal just means perpendicular, okay? Now, there's actually an easy way to just think about that in terms of a graph, and I'll show you that in a minute. But really, if you take the dot product of two vectors and you get 0, that means they are orthogonal. And I'll show you an example. So we'll just do something nice and easy. If we were to multiply or take the dot product of m and n, what's going to happen is we're going to get this. So we're going to multiply our I components, so 7 times 2, and we're going to add that to our multiplication of our components of j. So that would be 14 and a negative 1. That would give us 14 minus 14, which gives us 0. So hooray, we know these things are orthogonal. So if you thought about that in terms of graphically, though, remember, this is kind of just like our x and y. So if we went to 7, 14 and put our vector like this, and then we went to 2, negative 1, which is like this, they look perpendicular, but more importantly, think of their slope. Do j over I, or our y over x. That would be 14 over 7, which is 2. And then for n, we would have negative 1 over 2. And you should remember from geometry that opposite reciprocal slopes are perpendicular anyway. Okay, so all of this, again, it's all tied into things that we've done before. It's just applied in different ways. So at the end of this video, we will again talk about a physics type of example. So another thing you can do with these is you can find the angle between two vectors. And the way you would do that is you would take inverse cosine of the dot product of the vectors times the magnitude of each vector. So the formula looks a little something like this. And of course, if we're talking about vector A and B, we would use A and B instead of V and W. Now, the results of that, if you get 0 or 180, that means those two vectors are parallel. So something to keep in mind. Also, another thing is if you get 90 degrees, that's perpendicular. Now, once you find the dot product, if you get 0, you already know that they're going to be perpendicular, okay? So we're going to work with some that are not perpendicular, so you can see how that's done. So if we want to find the angle between vector v and vector w, the first thing you have to do is find the dot product. So v times w is going to be 2 times 5, and then plus your negative 4 times 6. That's going to give us 10 minus 24. So the dot product is a negative 14. Okay? So now what you have to do is you have to calculate the magnitude of each, and that's something that we've done before. So remember, the magnitude of vector v is going to be equal to the square root of 2 squared plus your negative 4 squared, and that's going to end up giving us 20. And it might be easier if you just left it as the square root of 20, because we're just going to end up typing this in our graphing calculator anyway to get the answer, so just leave it. But if you did type it, obviously you'll need a few decimal places to try to get it an accurate answer. So now we're going to find the magnitude of w again. And again, this is something you've done before. So we're just going to say if you take your 5 and 6 and put it into the formula, you're going to get 25 plus 36, which is going to give us the square root of 61. So now we're going to calculate the angle. So the angle is inverse cosine of, now we have our dot product, which is a negative 14, which we already found up there. And then we're going to multiply the magnitudes. So it would be the square root of 20 times the square root of 61. And we're just going to type all of that in our calculator, and we're going to find out that the angle is equal to 113.63 degrees. And that's how we find the angle. So, as I mentioned, this stuff gets used a lot with physics. So what we're going to do is we're going to do one physics example in this video. And basically, you're going to push a cart horizontally, on wheels obviously, with a force of 200 newtons up a 3-meter ramp that has an angle of 30 degrees. And we're going to calculate the work done. Okay? Now this is a physics example. This also could have different units. So we could have pounds and feet, which would give us like a pound-feet. And this one is going to give us newtons and meters, which is also known as a joule. We'll talk about that in a little bit. But anyway, that's what we are going to do here. Now, again, it's kind of helpful to think about this if you're drawing a picture. One nice thing is when you're pushing something horizontally, that means your angle is 0. So that'll give us a little bit less work to do. The work formula is force times the displacement. Displacement would be like your angle, and the type of, the ramp that you're working with. So we're going to have W is equal to our force vector times our displacement vector. So in terms of this, all you want to maybe think about is horizontally, you would be going 0. And then we're going to have our 3-meter, 30-degree ramp, and what we're going to do is we're going to calculate the force of this, okay, or the amount of work that is being done. So to do that, what we need to do is our force vector. Okay, so force for this one is we're using 200 newtons, and that's the cosine of 0 degrees because we're pushing horizontally, I hat, plus our 200 sine of 0 degrees, j hat, to get this in our component form. Now, because the cosine is going to be 1 at 0, again, you should already know this from the unit circle, but again, just use your graphing calculator if you have to. That's going to end up giving us 200 I hat plus 0 j hat. Now, we're going to go work with our displacement. So our displacement vector is going to be 3 and then the cosine of 30 degrees plus 3 sine of 30 degrees, because 3 is our, the number of meters we're going to be pushing this, and we're going to type that in our graphing calculator, and we are going to end up with 2.6 I hat plus 1.5 j hat. So now we just have to find our work, and to do that we're just going to use the dot product. So that means W is equal to F times D. And to do that, we're just going to use our dot product. So W is equal to, we're going to do our 200 times 2.6 plus, and now we need our J components, which is going to be 0 times 1.5. Now, of course, we know everything times 0 is 0. So this is going to give us 200 times 2.6 is 520. And this would be in Newton meters. Now, again, that's, and you can just say Newton meters, but that does have a fancy word in the physics world, and it's 520 joules. But that's it. That's just how you would use the dot product. Okay? So that's it for this video. This is Longo, and I'm out. See you, bye.